Yeah, it's really big. I mean, you can use it for, I don't know. There you can see the dispenser, so this part of the refueling station. So you have, zoom in a little bit, coming here from the high pressure storage that we saw before.
What kind of pressures are we talking about there?
1050 bar is a typical pressure range that we get asked for the electronic pressure sensors.
Okay, 1050.
And I mean, in the end, in the car, you have 700 bar.
Yes.
The Mirai or the Hyundai Nexo or the two cars that are out there actually today use a 700 bar system.
Yes.
But the requirement, the specification for our sensors, and this is typical for hydrogen refueling station, is 1050 bar.
Okay.
And a temperature range of -40 to 85 degrees plus.
-40 down. Okay. Good.
Yeah.
And then this goes so this one goes up to 1050.
Yeah.
And can you take us down the line
Absolutely.
a little bit further?
Yeah, then you have a flow measurement in here. You have various valves to control the system. You have a vent line also in case there's any emergency that the hydrogen is controlled and going really out to not build an explosive atmosphere.
Yeah, because there's a safety valve probably.
Absolutely, yeah. That's in here, and then it's controlled also by the measurements actually taken from the pressure sensor, from the temperature sensor, and also from the compressors, for example.
Yeah.
And then you have this chiller here that creates the -40 degrees. You need the -40 degrees because the hydrogen will warm up as it expands. So it's not a standard gas. A normal gas would cool down if you expand. Hydrogen does not. It will warm up. And because in the car you have so-called Type 4 hydrogen tanks.
Yes.
They are specified up to 85 degrees. They cannot take more. So you have to make sure that your temperature going into the car stays well below the 85 degrees. So that's why you pre-cool the hydrogen going into the car down to around -40 degrees.
So you're coming out here with -40. You go in here. What kind of ranges do you go?
Well, it's actually the hydrogen goes through here, and the chiller provides the
that's
cooling.
That's a heat exchanger here. Okay.
Yeah, basically.
Okay.
Yeah.
All right. Okay. So that gets cooled to
-40. Yeah.
Okay. So speaking of getting cooled, that means so you're measuring here if that is the case, and here you're dealing with what temperature range?
Well, it depends on what's coming really from the compressor, or in this case, actually the high pressure tank storage, because usually the filling is done using the high pressure tank storage, and then the compressor refills the high pressure tank storage, and then, well, if the tank sits there for a while, you're talking about ambient temperature.
Okay. Yeah. So, but now we talked a lot about temperature. Let's look at the sensor that measures exactly that. I know you brought one. It's a pretty impressive size.
Yeah.
Maybe you can tell us a little bit about that.
Yeah, it's really big. I mean, you can use it for, I don't know. But it's not the one. That's not the typical one used in a dispenser.
Yeah.
What you have in here, you have a tip with either a resistor or a thermocouple that creates either a resistor, a change of resistance, thermocouple, a change in voltage.
Yeah.
And this is then transmitted, through a transmitter.
Maybe we can put that here as well.
Put that in here.
So that we can see that. So we can see so there we can see.
that works,
Yeah, exactly. So maybe you can take us through what this is.
If you bend it down a little bit.
Yeah,
perfect.
Okay.
So that's a temperature transmitter that's connected to the tip, so to say. And this takes the resistance value or the change of voltage in case of a thermocouple, and transfers this into again 4 to 20 milliamp output signal that can easily be used at the controls of the hydrogen refueling station.
Okay. And this goes out there, and you have this. This is shock protection. Or why is it such a big, colorful cover?
It's actually it's a mechanical protection on the one hand side. It's also a safety issue because all of this, what we are talking about here, all the instrumentation has to be explosion proof. So we are talking about ATEX or IECX requirements or local certifications, and this adds additional safety that nobody really is able, first of all, to get down to the transmitter, and also protects from the environment.
Okay. And so obviously safety is a big topic, but is there any other thing that distinguishes this from, let me say, your usual temperature sensor, which you can buy for a couple of cents?
Well, to be honest, especially in the portfolio that we have in electric temperature, almost anything we have can be used in hydrogen.